Excuse me, welcome to another video. Today we're going to talk about loops. So far for this course, we've talked about code that runs sequential. In other words, it executes the first line of code, then the second line of code, third line of code, all the way to the end. And then in the last couple of weeks, we've talked about if statements, which allows us to be able to, remember, that allows like a fork in the road so that we're able to execute some code while we don't execute others, depending on certain conditions, like variables are worth certain values or whatever. If that seems kind of fuzzy, you may want to go back and look at the if statement video or the lecture notes. I'm not going to say a whole lot about that right now. Hopefully that's still kind of fresh in your mind. But there are times that we want to be able to repeat code, do something over and over again, and that's where loops come in at. And we usually loop until a certain condition becomes true or it becomes false, depending on how you want to look at it, or how the structure's set up. We've got several different looping structures, so depends on the looping structure if you want to look at the condition being true or being false while it's executing. So the best way to look at this is, let's go ahead and look at a couple examples. So let me copy and paste the first one into our little compiler thing here. Let's make this look a little prettier. So this is roughly the way you want this. If just with one statement like this print statement, having it the way I had it before was fine. But if you have two or more statements, generally you want it to look something similar to this, to where you have a for loop, and then you have your open bracket here, and then your closing bracket there. Sometimes you will see it written like this as well, where you've got your bracket here, your opening bracket there, and your closing bracket there. Either of those work fine. I kind of like writing it like this because it's one less line of code. So what happens here is, this is a loop. This is called a for loop. And what we do is the value of I starts at 0 and it continues until it hits 3. Then once it hits 3, it exits out of the loop. This right here that I've got highlighted, that should look somewhat familiar to you if you watch the Swift or the switch video. The switch video, remember we had ranges in there, to where if a variable was within a certain range, this is exactly the same thing. This is a range. This is a range of 0 to less than 3. So it's 0, 1, and 2. So it's those three numbers. And so what gets printed here, the first time through the loop, I is equal to 1, and so it prints out, I is equal to 0, and it prints out 0. Second time through, I is equal to 1, so it prints out 1. Third time through, it prints out 2. Then after that, it comes out of the loop. So what I'm going to do here to make this a little bit clearer is to write it like this. And so if we click on Run, okay, we've got the following output. We've got I is equal to 0 first time through. Second time through is I equal to 1, and then the third time through is I is equal to 2. So it goes through this loop 3 times, changing the value of I each time through the loop. Now, instead of writing it like this, we could also write it like this. 1, 2, 3, 3 dots. Write it like that. Let me comment out this code. We do that with slashes. We can click Run. Okay, and it produces 0, 1, and 2. So notice this is the same output as what we had here, because here we're saying that this range is 0 to a value that's less than 3, which is 0, 1, and 2, or you could write it like this. I like this way better, but there are cases to where this possibly could work. Let's say, for example, I'm kind of getting out of the notes here, but let's say we got a variable, num, or let's call it times, num times equal to 4. And this could be calculated somehow. Somehow we get the value of 4 in here. Oops, let me write that again. Num times equal to 4. We can say 4I in 0, 3 num times. Let me comment this out so that way it's a little bit easier for us to read. Maybe pause the video, try to figure out what this is going to happen. Let's also change this. I don't want to just use I all the time. We can use another variable name. I like using I and J. You'll notice a lot of programmers do that, or they'll use X, Y, and Z. It's very easy to use. This is a temporary variable. It's only known in this loop. So if we execute this, notice here it counts from 0 to 4. So we can change this variable to different values, or we can have it calculate things, whatever, and then have it print out values. So these don't have to be hard coded in. This doesn't have to have a value of 2 there. We could actually use a variable here. We could also use a variable here at the front too, if we'd like. So that's just an example, something to keep in mind. Also, there's times to where you may want to count in reverse. So one way of doing that, with what we've learned so far with for loops, is to write it this way. And what I'm going to do is I'm going to go ahead and clear all of this out. Let's put this here. And what happens here is really the magic that's going on occurs right here. What happens is we create a range 0, 1, 2, and then the reversed function. Remember, this is similar to the string function that's called reverse. It does the same thing as the string does. It just reverses those numbers. So instead of it being 0, 1, 2, it'll be 2, 1, 0. So if we execute this, what should be printed over here is 2, 1, 0. And I'll go ahead and change this to some other value. Let's say A, just to give another example of what that is. And notice here, A is equal to 2 the first time through the loop, A is equal to 1 the second time through the loop, and A is equal to 0 the third time through the loop. Now I'll leave it as an exercise for you, maybe to remove the reversed. Well, actually, let's just go ahead and do that. We click Run. Notice it does 0, 1, 2. Okay, let's look at the notes. Actually, I want to look at the notes here. Sometimes we want to, whenever we're going through the loop, each time we go through the loop, we don't want to just add 1. We want to add some other number, maybe like 2 or 3 or 4 or something like that. Swift provides a function called stride, which you can think of that as steps. A lot of other languages will use steps instead of the word stride, but for some reason Swift likes to use stride. And what that does is it says, okay, what if you're not wanting to increment by each time through the loop, increment your variable by 1, what do you want to increment it by? So there's a stride function that can create a range. We can go from 4 to 0 by a value of -2. So it should start at 4 and it will count down to 0. One thing that is neat to point out is sometimes with like ranges like this, you got to figure out, okay, does it include the value 0 or doesn't it include the value 0? We know it'll start at 4, so it'll say 4 2, and 0, but will it actually execute and print out the value for 0, or does it leave it off? Let's see what it does. Okay, this is a little bit deceptive because I would, in a lot of languages, it actually includes this last value here, which would be 0, but Swift does not do that. It goes forward 2, and then it doesn't, once your value of I is equal to this value of the 2, it exits out of the loop. So that's something to keep in mind. And this is the value we're adding to I each time through. So the first time through the loop, I is equal to 4. Second time through the loop, so let's do that. First time through the loop, I is equal to 4. Second time through the loop, I is equal to I minus 2, which is really 2, because remember, I is equal to 4. So now I is equal to the value of 2. Then the next time through the loop, I is equal to I minus 2 again, which is 2. This value here minus is 2. Then 2 minus 2 gives us a new value of I, which is 0. So we go 4, 2, 0. So play around with different values here and see what happens. You know, maybe put this value to be -1 and see what happens. It should probably include the 0 here. It should be 4, 2, 0, I think, with running this. Let's run it and let's see what happens. Yep, that's exactly what it does. Now, if you put a -2 here, let's say, it's going to count from 4 down to -2 by a value of 2 each time. So go 4, 2, 0, -2. From what we learned about the 0, whenever 0 was here, -2 won't be included with that. So you can see here. So play around with these different values. You could also do like a 2 here and see what happens. Oh, nothing gets printed. Okay, I was expecting that. I know most of you probably wouldn't. The reason for that is because we're starting from 4, going down to -2 by 2. Well, we're adding 2 to I each time. So this never gets printed because our range starts at 4, goes down to -2. Well, we're not in that range. So it doesn't print out anything. Now you could think, well, maybe the first time, because I is equal to 4, it would actually execute this at least once, but it doesn't, because this value here is the 2 is less than 4, and we're actually adding each time. So the only time we're in this range is the first time, and the way that Swift has got this set up, it just never prints this. Other languages that does something similar to this, it may actually print the first 4. It may print out 4 out here, and then that's it, and then exit out of the loop. Some languages will do that, but Swift is one of those that does not. So if you want this to work, okay, let's do this. You remember in the first example, we had something like this. And remember that printed out 0, 1, and 2. Now, whenever I put a comma here, really, they're supposed to be on different lines, 0, 1, and 2. But I'll just print them out this way, because that way I can have them all on one line. So, well, really, I could write it like this, but it just takes up more space. And I'll do that for this example. But quite often, if you see something like this, it's implied that a print statement prints something on a line and then goes to the next line. And so this is a shortcut or shorthand representation of this. At least that's what I do. Some other instructors may say, no, this isn't the exact same thing, but I let it slide, at least for a lot of my stuff, because at least if you put a note there saying, hey, this is supposed to represent one item on each line, rather than writing it like this. So with the stride function, we can actually replicate this here, this I. And now, why would you ever really do that in real code? You wouldn't, but it's just another example to show you how stride works, and you can actually get it to work if you want. You'd write it like this. You'd say for I in stride from 0 to 3, because remember, the last value does not get included in our loop. Remember, we do a print or we execute this loop here, and then we say we add 1 to it each time. So what's going to happen is it'll execute this loop, and we'll print out 0, 1, and 2. And then this one down here will print out the same thing. So we get 0, 1, 2, and then 0, 1, 2. Okay, yeah, that's exactly what we got, 0, 1, 2, and then 0, 1, 2. So you can replicate this for loop by writing it like this with a stride. Now, why would you ever do that? I don't know. You could write it this way and have a variable here for the step, and let's say you don't know what the step is going to be. That's one way that you could write a stride and do it this way. And so this could be 1, 2, you know, it could be any value here, or it could be something you ask the user, or you could create some arithmetic that calculates the step. That's the only real world case that I can think of that you would use a stride over something like this, is that the step could be a value of 1, or it could be some other value like 2, you know, -1, -2, or some other value. So you could write it like this if you wanted to, if you were calculating what the step would be. And there are times that you will do that. But if you know you're just 9 times out of 10, though, you're just, okay, let me go ahead and put a 1 here and let me try that. Because we had a 1 there, I changed it to a variable step. So we should get the same thing that we got before. Notice we did get the same thing we got before. But 9 times out of 10, or 99 times out of 100, whenever you write loops, you'll want to increment by 1 each time. You just count 0, 1, 2, 3, 4, whatever, because you're doing something. You're doing some kind of a task, and you just want to add 1 each time to calculate something. So let's move along. There's some other examples here. I'll let you do those if you want to get an idea of what's going on. Let's look at a real world example. There's something called the Fibonacci sequence, and you can Google that. You don't have to know a lot of the background to what it is, like who came up with it or whatever, but it's an example that's used a lot in computer science to do loops and things like that, to show examples of stuff. And what you do is you start off with 2 variables. You set one equal to 0, the other one equal to 1. And then to calculate the next value in the sequence, so we start with 0 and then 1. The next value in the sequence is the 2 previous values added together. Notice here, whenever we got 0 and 1, the next value after that is 1. Well, that's just 0 plus 1. How did we get the 2 here? We just take the 2 values before it and add them together. How do we get the 3? We add the 2 values before it, 1 and 2, and we get a 3. So like over here for 55, how we get it is we take the 2 values before it, 21 and 34, and we come up with 55. So we can write code to reproduce this. This is an interesting property. One of the things behind it is back a couple hundred years ago, a mathematician wanted to see how fast rabbits could multiply. And he noticed that whenever he was in his notes, as he was keeping track of how fast rabbits could multiply, he noticed that the sequence of numbers that he was getting was similar to this. And so this guy, I assume his name's Fibonacci. I can't really remember, to be honest with you. It's been a little while since I've looked at it, but I remember the rabbit story. The number of rabbits that he's getting was similar to this, to where they weren't doubling every month or every couple months, but he noticed this property that he could predict the next number by just adding up the two previous numbers. So let's do this same thing. Let's write this code. We can write this code in about 5 or 6 lines of code to produce what we want. I mean, we can produce this sequence of numbers. We can take this code here and let's get rid of this. And so what we do is we create two variables, for F0 and F1. We can just two variables, let's call them A and B. We set one equal to 0, the other one to 1. Print out those two values, and then we'll use a for loop that just counts from 2 to some value, let's say 50, to figure out what the first 50 values of Fibonacci are. And what we do is we create another variable, I'm going to call it C, and we just add the two previous values together. Then what we'll do is we'll print out that value, and then we just change the values of A and B to be, A will be the old value of B, and B now becomes the value of C we just calculated. So each time through this loop, we're just moving down our list. Now you can change 50 to whatever you want. Let's see if this runs. Let's see if this will actually run in this compiler. I'm not sure if it will or not, because since this is in a web environment, sometimes things work and sometimes they don't. Okay, it actually does run. I think we get something up here. Okay, we don't ever use the value of I, so that's why we get this warning. It says I was never used. Consider replacing it with the underscore or removing it. You can create a dummy variable by just putting in an underscore here. Since we never use I, notice here we never use I, it's not really needed. So let's run that again. Let's see if we get rid of that warning. Okay, we do. So notice here our Fibonacci sequence. We start off with 0, then we get 1, and then we get 1 again, because this value of 1 is just these two up above it added together. 0 plus 1 is 1. To get the next value, we take the two previous values, 1, and add the two together. So we get 1 plus 1, we get 2. To get the value of 3, we just take the two values above it, the 1 and the 2, and we get 3. Notice the pattern here. So I would say, learn what the Fibonacci sequence is. Try to understand what this is, because if you take any other classes that I teach, I almost always use the Fibonacci sequence somewhere. And so if you understand it now, if you take my other classes, then you won't have to worry about it too much. And if you talk to other computer people, every once in a while, somebody may say something about Fibonacci sequence or something like that. And if you kind of know what they're talking about, I don't know. It's just one of those things that's, at least in the circles that I've been in, they kind of expect you to kind of know what that stuff is. So, it's probably good to at least know what it is. So, look at this code here. You should be able to figure out roughly what's going on here. Everything that we're doing here, we've done before. The reason why we use a var here is because we will be updating the values of A and B as we execute the code, so we don't want to use a let. If you use a let, it's going to complain down here whenever you change the values. We can get away with using a let here because we're in this loop, and once we get done executing this loop, Swift sees this variable as a C. It's never changing. Each time through the loop, it creates a new variable called C. And even though the code may not actually do that, it just lets Swift know that this is a temporary variable. If you put a var here, I believe that it complains about it. Let's try and see what it does. Yeah, I think it complains about it. Yeah. Warning variable C was never mutated. In other words, it was never changed. That's what they mean by never mutated. Consider changing it to a let constant. So you put a let there just to get rid of the warning. And because once you set C equal to whatever value this is, A plus B, then C never changes in this loop. Actually, I'm fine with somebody writing a bar here. I wouldn't take off for it. But the compiler seems to be a little more anal about it than I am. So the proper way would be to go ahead and probably write it as a let. Notice how big these numbers get just with 50 iterations of this. So this is a big number. Let's see. That's like a billion or something, 1.8 billion. So just 50 iterations, generations of this, we're already up to a billion rabbits. That's crazy. But this is neat. This is about 10 lines of code, well 13 if you count everything with the spaces and stuff like that, and well if you use this import. But from 3 to 13, that's about 10 lines of code. This is a really slick solution to the Fibonacci sequence. It's very eloquent. Nice little solution here. And so notice here that these, we calculate C, and then we print out C, and then here all we're doing is changing our bookkeeping a little bit. We're just changing the values of A and B to what B was before and then what C is. So this is a neat little example to play around with, maybe change the value a little bit. You will put it, there is a possibility you could put in a large value to where this complains over here, but play around with it, see what happens. Like I said, you really can't break a whole lot of things, or if you do, you just refresh the browser and start over. There's other loops that we can learn. The most important one is the one we learned up here, the for loop, a for-in loop. But there are times to where you could use these others, like the repeat while loop, to where you actually want to execute this statement at least once. And so let's look at this. Let's look at this example. I almost always write my loops as the for loops. But every once in a while you might have to write something to where you have to write it similar to this. So I want you guys to know that this exists. And there's a possibility it could always be on an exam anyways. And there probably will be a few examples on an exam. But I almost always tell my students, if you can write it as a for loop, try to do that because it's usually cleaner that way. These other loops start getting a little bit messier, but sometimes they are the best way to write the code. So what happens here is we create a variable called I, and we set it equal to 0. And I went ahead and wrote it like this, so that way we made sure that it was an integer, even though I think it's going to be an integer anyways. And then we repeat this code here while I is less than 3. So here's a repeat statement. We will print out the value of I. We will then add 1 to I. And then we check to see if I is less than 3. If it is, then we come up here to the top and start executing it again. So this should print out 0, 1, and 2, which is what we've been doing so far. So this is equivalent, this for loop here, or this while loop here, is equivalent to writing the following: for I in 0 to print I. Notice I'm able to fit that all on one line, 2 lines max. This is a little bit bigger. Notice that the for loop, what it does down here, it automatically adds 1 to a value of I each time through the loop. In a repeat like this, you have to do that work yourself. So you could write it like this and it would be fine, but you're having to do more of the work yourself. It's a little bit harder to read. Somebody would probably look at this and say, hey, why didn't you just write a for loop? Or why are you writing it this way? Also, the compiler is able to see this and be able to optimize the code a little bit better. This will probably be less optimized. It would take a really smart compiler to realize that this is the equivalent to this. And so if you can write it as a for loop, do it, but there are times to where you can't do that. One of the things is whenever you're getting user input, you're asking user to input values from the keyboard, and that's one of the disadvantages of using this Swift compiler on the web. I haven't found a good way of doing that, so the way I've had to do it is just by initializing variables to values, and do it that way. So notice here we could change these values if we want to. Let's do this. If we change I equal to 3, what happens? Well, since we're first executing this before we do this comparison, it'll print out 3, it'll add 1 to I, which will be 4, and then while 4 is less than 3. Well, that is going to be a false statement, so it will just not execute anymore. So this will just print out the value of 3. Let's see if that's actually what it does. Yes. So you could put any value you want in here for I. It will execute this at least once. And then whenever we get down here for the while, it does a comparison, and then it figures out if it really needs to repeat this, these statements or not. So that is the repeat while. And there's a mistake here. This actually should be up on here. I'll try to fix that, but I'm not going to redo the video for that. You could remember with the switch statement where we had the where statement and we did the evens numbers. That's roughly what's going on here. Is let's say you want to only print out the even numbers. You could do for I in zeros to less than 5, where I mod 2 is equal to 0. In other words, what this means is this value even or not? Because the only time you get a remainder on a mod that's 0 is, in this case, is whenever it's even. So if we execute this code, let's take this, put it up here. Actually, it'd be nicer to write it like this. What it'll do is it'll print out I. Okay, it starts at 0. It'll print out 0. Whenever we get a value of 1 for I, it checks to see if I mod 2 is equal to 0. It's not. It'll just equal 1. So we don't execute this. We go to where I is equal to 2. And another thing you could do here is you could say print I mod 2. See what it is. If you notice, this will always equal the value of 0. So we'll have 0, 0, 0, 2, 0, 4. Now, actually, let me write it like this. So that way it's on one line. Yeah, so notice that I mod 2 only, well, this print statement only gets executed when this where statement is also true. So I mod 2 double equals 0. Notice that that's what this value always is over here. Now this value of I, the only time that I is printed down here is when this condition 0, which is always the even number, 0, 2, and 4. We could play around with this a little bit. For I in 0, 5, and then down here we could print out I, and let's say we didn't know what I mod 2 was, or let's keep it in the same order. Let's say you're just trying to figure out what's going on. So let me comment this out so that way we don't got too much stuff being printed here. So yeah, notice here we've got I mod 2, so it goes 0, 1, 0, 1, 0, 1. So that's what this will always return, is a 0 or a 1. It'll always return a remainder. You can think of I mod 2 as the remainder of a fraction, like I divided by 2 is going to return a remainder of 0 or 1. And I mod 3 is going to be 0, 1, or 2. But notice here, this is, I is equal to 0 first time through. When I is equal to 1, the remainder is 1. When I is equal to 2, it's 0. When I is equal to 3, the remainder is going to be a 1, because we're doing I divided by 2. So we could also put out here this. To 2 and then put R. And R is going to be the remainder. So let's see what this does. Yeah, I knew I didn't do something right. Yeah, forgot a comma there. Yeah, so 0 divided by 2 is equal to 0 with a remainder of 0. I divided by, or 1 divided by 2 is equal to 0 with a remainder of 1. 2 divided by 2 is equal to 1 with a remainder of 0. 3 divided by 2 is 1 with a remainder of 1. 4 divided by 2 is 2 with a remainder of 0. So that's probably the best way to look at this. I think that makes it a little clearer, and then your values of I are also out here. So if you're having trouble with the modulus operator, this is kind of a good example for that. You may need to do a little bit of reading off to the side to get up to date on that, on exactly what that is if you're still having trouble. There's also, we talked about the repeat while. There's also a while loop. That we can talk about. We can have some variable. We can check to see while I is, so here's our condition, here's our body here, and each time through the loop we're adding 1 to I, and we're going to do this until this condition is not true anymore. First time through the loop, we check to see if count is less than 10. I is less than 10, so we execute this body. This is the first run of the loop. Then we add 1 to count. Count now becomes 2. So is 2 still less than 10? It is, so we print this out for the second execution of the loop. We add 1 to count. And so one of the things that we could do here is, well, count is being shown because we have it right here. So this is the first run, this is the second run. Notice each time through the loop, we are adding 1 to count. We don't have to just necessarily add 1. We could add 2, for example. Let's see what happens. Well, if we do this, we add, we go through and say, okay, we start off with count equal to 1. Count is, 1 is less than 10. So we print this out. And then we add 2 to count, so now count is equal to 3. While 3 is less than 10, that is a true statement. So we print out 3. We print out this is the third run of the loop. Then we add 2 more to count, which is 5. 3 plus 2 is 5. And another thing is, notice that you could write the count like this, which it adds count to itself. Or you could write it like this, count is equal to count plus 2. This statement and this statement are equivalent. This is just a shorthand way of writing this. I may not have told you guys about that, but in your C-based languages, many of them allow you to write, you know, if you're adding a value to a variable, you can write it like this, but this is equivalent to this. Okay, moving right along. There's times that whenever we're in a loop, we'll want to break out of it for some weird example. Maybe some weird condition occurs or something odd happens and you're just like, hey, I need to get out of this thing early for some reason. Maybe there's an error or there's some kind of a weird condition that's occurring. So to make this look a little prettier, So here's a for loop for I in 0 to 10. So here's our range to 0 to 10. We check to see if I is equal to 7. If it is, we break out of the loop. If I is anything but 7, well, we break out of the loop, or we continue by going to a print statement. So whenever we execute this, we'll start counting. And whenever we get to 7, we break out of the loop. So we could put here print after loop. And up here, we could say print before loop and see how this runs. Now before the loop, then whenever we get in the loop, I is equal to 1 or equal to 0, the first value here. So we check to see if I is equal to 7. So 0 is equal to 7. That's a false statement. So we don't execute this. We just go ahead and print out the value of I, which is 0. We hit this end of loop statement or end of our body. So we go back up here to the for loop. We add 1 to I. So now I is equal to 1. So if 1 is equal to 7, we break. That's not a true statement. So then we print out 1, come back up here. We add 1 to I again. And so now I is equal to 2. And you notice what happens. When I finally is equal to 7, we break out of the loop and we print out after loop. So I never prints out 7 because we execute this first, which it then breaks out of the loop. So try some different values here, see what works, see what doesn't work, maybe change the value of I to some other value, let's say 5, print it, see what happens. Notice it does the same thing, except that instead of printing out 5 or anything after, it just exits out of the loop. So that's one way you can play around with break statements to break out of a loop if you need to. Okay. We haven't talked about something called arrays yet, but I do want to show you an example of this, just so that you're aware that this does exist. And whenever we get to arrays later on in the semester, we'll look at these examples again. One thing that's very powerful about for loops is that we're able to go through the items in an array. You just think of an array as a list of items. So in this case, we've got a shopping list. It contains 3 values: milk, eggs, and bread. So instead of counting like what we've done before, we're able to go through each item in our list. And so what we're going to do is that for each item in the shopping list, we're then going to print out a statement that says, please buy in that item. So the first time through, item is equal to the first item of the list, which is milk. And then we're going to print out, please buy, and then milk. The second time through the loop, item now becomes eggs, and we then print out, please buy eggs. And then the third time through to be bread. Okay, so you may want to try adding another item to the list. Say bologna. See what happens. It's going to add bologna to the list. Well, we could remove something if we wanted to. Let's say we don't need eggs. Compile it, run it, milk, bread, and bologna. So you could change the arrangement of items in the list. Now, one thing you can't do, notice that all of these are strings in here. You cannot do something like this. You cannot put in a number. This has to be a string. And it complains about that. Homogeneous collection, literal, blah, blah, blah. If you want to have some kind of a number, it needs to be between double quotes, and then Swift is happy because this is now a string. So that's reason why I wanted to show that example, not so much about the array stuff, but to help you to remember that 1 does not equal 1. In almost every language, that's the case. So learn it now that the number 1 is not equal to a string 1. All right, I think that's about it for this lecture. Hopefully you've learned something. Go back to certain parts if you need to. If something's not clear, let me know. I can try to straighten it out. I can send out another explanation, create another video, whatever needs to happen to try to clarify something. So have a good day.